All right, in this video, we're going to talk about heat calculations and specific heat. And so what we need to remember is the heat equation, Q equals mc delta T. We'll write my T a little better there. Now remember, Q is our energy, M is our mass, C is our specific heat, and delta T is the change in temperature. So our first question, how much energy is needed to raise the temperature of 50 milliliters of water from 10 degrees Celsius to 90 degrees Celsius? All we want to do is get in the habit of substituting. Q equals mc delta T. Q, how much energy? We're trying to solve for Q. We know the mass because of the milliliter value for water, because we know the density of water is 1 gram per milliliter. So if I have 50 milliliters of water, I have 50 grams of water. So 50 grams of water, and according to our New York State reference table in table B specifically, we can find the specific heat of water, which is 4.18 joules per gram degrees Celsius. And in this case, my temperature change, it went from 10 to 90. We always do the final minus initial, so 90 minus 10 is 80 degrees Celsius. And so what happens is my grams are going to cancel out, my degrees Celsius will cancel out, and I'll be left with a unit of joules. And so when we do that calculation, 50 times 4.18 times 80, we get 16,720, and that would be joules. 16,720 joules. Again, I'm not doing anything with significant figures or sig figs in this question. We're just giving the actual setup. Now, in some cases on the Regents exam, they will ask you just for the correct numerical setup, and this part right here would have been where you could have stopped your answer, the correct numerical setup. You showed the substitution for each of those pieces, and a lot of times the state doesn't even ask for that. So be careful when you're looking for that. On the test, just to see if it's looking for the correct numerical setup, they want you to show this. If you just put an answer, you're not going to get the correct point for that. So this one we solve for energy. This one we're going to use the same equation, but we're going to solve for specific heat. What is the specific heat of an unknown 30-gram substance if 10,000 joules are added and raise its temperature from 87 to 100 degrees, or 102 degrees? So again, we want to get in the habit of using our equation. Q equals mc delta T. So Q equals mc delta T. What can we solve for? Joules are my energy. So I know 10,000 joules are added. I know the mass of the substance is 30 grams. I want to know what is the specific heat. I want to know what C is. And the temperature went from 87 to 102. So when we subtract, my temperature went up 15 degrees Celsius. Okay. So now it's a little bit of a different calculation. I need to get the C by itself. And mathematically, we'll just change the angle here for a brief second. You'll kind of lose part of my face. The math is more important, of course. Mathematically, I want to get C by itself, so I need to eliminate these two values, the 15 and the 30. That means I got to divide both sides by 30, divide both sides by 15. That means I need to do it over here. 30 grams, and we have 15 degrees Celsius. And that's how we're going to end up with our units, joules per gram degree Celsius, because again, we're solving for specific heat. So again, those cancel, we're left with C. When I recalculate and do my question, and I'm solving for, solving for C, not for Q, solving for C, when we do the math, 1,000 divided by 30 divided by 15. Okay, if you want to do this math first, 30 times 15 and get an answer, and then do 10,000 divided by that, that's fine. Otherwise, I believe I might have said 1,000 a minute ago, but it's 10,000 divided by 30 divided by 15. Anything that's on the bottom is divided by. And what we get for an answer is 22.2 repeating. And again, it would be joules, gram, degrees Celsius. I apologize that it's going off the bottom of the board. It might be a little bit hard to see. But there you have it. That's two examples of using our Q equals mc delta T equation. And calculating heat for New York State Regents and just for chemistry classes in general. Now, we could have solved for delta T. We could have solved for the M as well. And one of the questions that often come up is they will ask, what is the final temperature? And so that's something you have to be careful of, because if you're doing your math calculations, a lot of times people will just look at the temperature change, not the final calculation. So let's look at one more example. We'll do a third example here, just to show you what we mean there. And so I'm going to use these similar numbers. So how much energy is needed to raise the temperature of water? 102. Let me see. We're going to change this. So we have, let's say 1,000 joules is added. We're going to say is added. Okay, so 1,000 joules added to 50 milliliters of water at 10 degrees. And I'm just doing this kind of spur of the moment here. So 1,000 joules is added to 50 milliliters of water at 10 degrees, ... What is the final temperature? Okay, so again, if we're going to look at this, Q equals MC delta T. I know my Q is 1,000 joules. Again, my M, because milliliters are equal in a 1-to-1 ratio for density of water, 50 mils is 50 grams. I know the specific heat of water again is 4.18 joules per gram degrees Celsius, and I want to know delta T. I need to figure out what the temperature change is first, even though the question asks what is the final temperature. So make sure you're very careful and you're wary of this. So when I get rid of this and move these numbers around, just like we did in the previous question at the bottom, I got to divide this side by 50, divide this side by 4.18. Really, I'm going to divide this side by 50 grams, and also I'm going to divide this side by 4.18 joules per gram degrees Celsius. So I'm going to be left with Celsius because I have a joule and I have a joule, I have a gram and I have a gram. The only thing I'm left with is Celsius. So now we have 1,000 divided by 50 divided by 4.18 is the temperature change. Okay, that's our temperature change. And so I'm just going to run off the screen for a minute because I don't have a handy calculator. I'm going to actually calculate this right now. 1,000 divided by 50 divided by 4.18. So give me 1 second, and we will be right back with you. So 1,000 divided by 50 divided by 4.18, and we get 0.005. So 0.005. That's not a lot. 0.005. And if we think about this, we have 1,000 divided by, in this case, this would be 1,000 divided by 20. And I think I might have done one little error. Again, I'm just kind of doing this off the cuff. 1,000 divided by 200 should be 5, not, hold on 1 second here. Make sure I clear my calculator out. There we go. Yeah, I think I hit the wrong number. 4.78, which rounds up to 5. Okay, apologize for that. 4.78 degrees, which we're going to call 5 degrees for the sake of the math. And so just looking at this, again, this is where I checked. One of the things you can always do is check your math, is just see if it makes sense. And so 50 times this, if we round this to 4, 50 times 4 is 200. 1,000 divided by 200 is of course 5, not 0.005. And so I just had a decimal error. And again, it's okay to make mistakes. Just go through and check your work, okay? You can see even as a teacher, sometimes I'm trying to go really fast. I just pulled those numbers up. I did the original calculations for the first two, but I didn't do it for the third one. But that's okay. Failure is okay. It's okay to make mistakes as long as you learn from those mistakes and then you don't make them on the exam. So something like this, 5 degrees is the temperature change. That's the delta T. But the question really wants to know, 1,000 joules is added at 10 degrees. What's the final temperature? Because they were added, because the energy is added, that's going to cause our temperature to go up. Sorry, the purple didn't show up very well. Because the temperature originally was 10 degrees, the energy was added. So now, because we were at 10, we are going to go to 15 degrees Celsius. So that's just something you need to be aware of. It doesn't often happen on the Regents exam, but that doesn't mean it couldn't happen on future Regents exams. So hopefully you found some benefit. Again, I apologize for making the math error and having to run over to the calculator. I didn't have one handy in my hands. And again, I just kind of made that up spur of the moment. So again, Mr. Gardner here with Regents Chemistry and chemistry in general. Hopefully that you found some benefit from this and it will help you on your next heat or thermal chemistry calculations. And we look forward to hearing about your success. Take care.